Hi and welcome to this video in the MRDCL Fundamental series, in which we look at how you can improve your run times on big projects. Now, these aren't all the things by any means, but these are the most common things that we find in support that can actually damage your run times and where you can make simple changes to improve your run time significantly on a big project. On a small project, it probably really doesn't matter. But on a big project, you might be wasting a lot of time with runs that perhaps can be cut, in some cases, down to just a small percentage of the time they take to run without these changes. So let's look at the examples we have here. And the first one here is avoiding unnecessary MVARs. Now, one thing I've seen is perhaps this sometimes appears in software or scripts that have been generated by other software where inefficient script is driven out. And here's an example. This project here, for example, has ASCII data. It's got card characters, yet it's picking up every field in the data from 1 to 200 as a multi. Now that's just impossible. It can't be multi. It would have, in this particular case, it could be single. So make it single. Multi-variables are much slower to run, and I have seen runs where there's thousands of multi-fields that really just aren't necessary. If they can be single, make them single, and that applies to all variables. And the bigger the multi is, the more important it is to make it single if it can be single. Obviously, if it can't be single, it's got to remain a multi. So that's the first thing to suggest. If a field should be single or can be single, make it single. And just to explain why that is, and the rationale for that is that what MRDCL is doing behind the scenes with a single, it's actually just storing an integer value or a numeric value. So if a respondent for this particular piece of this line of code here had 8, it's just storing that as an 8. Whereas if it's multi-data, it needs to store all the different answers that may be possible. And if they're single, it's storing them, if you like, in this particular case, as 10 answers which are true or false. So the code needed to behind the scenes to store that information and process that information is much weightier and will slow your runs down. Again, if you've got one variable or two variables, it really doesn't matter. It's where you've got large numbers. And the same is true with the second example here, or similar example here. I've seen this typically when people are backcoding data, that they want to backcode perhaps some coded data that they've got in a spreadsheet back to another variable. And it's tempting just to sort of do what's the quickest thing to do and define a variable. I've seen quite often of 999 responses or 9,999. And you can see in the latest version of MRDCL, we've actually upped that limit to 30,000. Now, that's a good thing, of course, because it means you can handle multi-variables that are as big as 30,000 responses. But, of course, it's a dangerous thing in the sense that you could just indiscriminately specify a variable of 30,000 responses, but actually only use a couple of them. So there's an example here where we're only using codes 1, 2, and 3 in my backcoding, albeit in a rather small, simple, and unlikely example, but 30,000 codes have been allocated. Now, again, if that's one variable, it probably won't matter too much, but if you've got lots of variables of that particular size, you're going to start to impact. The third example is one, again, where I've seen particularly common when you're backcoding data. Perhaps you've got some data in a spreadsheet that you want to backcode, and you've got it on a respondent by respondent basis. And what you have is if a serial number is 1, you make question 23, if it's 2, 14, and so on. Now, again, in my example of 5 if statements there, that's not inefficient. That doesn't matter very much. But if the sample size was, let's say, 30,000 respondents, and we were doing 50 questions that way, that would be a lot of if statements. And it could be a much less than that, and there would still be a lot of if statements. So there is another way of doing it when you want to backcode one single value to each respondent. Now, the code looks a little bit more untidy, I always think, but nonetheless, it is really efficient code and will run it in a fraction of the time. So I'm defining a variable here called x serials, which picks up the serial number. So in this case, 1, 2, 3, 4, 5. And then I'm defining an integer, which I'm setting which is the same as this: 23, 14, 12, 9 and 17. So for the 5 codes in here, I'm allocating 23, 14, 12, 9 and 17, if you like, on a one-for-one basis. So the first respondent, or respondent 1, gets 23, respondent 2 gets 14, down to respondent 5 gets 17. And then I can pick up in my final variable, which is what we call question here, the integer value. Now that's 3 very simple lines of code which are infinitely more efficient if you've got any number of if statements. So again, I'd always encourage you to do back coding where possible that way. And the final example we've got here, if I just scroll down, is the rule that always make variables temporary if you can. So if you're picking up perhaps a multi-question here from 21 to 40, and all you're going to do is combine it together in another variable, well, the best thing you should do is make this variable temporary, because you're actually wasting, if you like, a variable of 20 responses here that's never going to be used in tables, not going to be written away. And if it's not going to be written away, you'll make your exports easier if you make them temporary. And you do that by putting an X on the front of the variable name, and that variable does not get written to the IDF, can't be used in tables, and is not exported. So it actually comes much cleaner. So if you've got any variables that are just building blocks that you're using for variables you're going to use for some other purpose, always make them temporary. Now, you can, with a lot of temporary variables, run out of space, but there is a command, a temporary command, where you can say temporary at the top of your script, temporary / where n is a value, and you can set that so that you increase the size. And that's all covered in the help if you want to know the exact syntax of a temporary statement, and you can expand the temporary space. And again, you'll get much more efficient runtimes. So all these things really apply where you've got a big project, or you've got lots of code that's repetitive like this, where you can actually do it in a much more efficient way that will run significantly quicker. And we have seen runs that have come down in time from perhaps taking 20 minutes down to just 10 seconds, just by changing the way the code has been specified. Well, I hope that's been useful to you, and thank you for joining me.